Assalamualaikum warahmatullahi wabarakatuh. We are from group F from S2G1 and today we're going to present about our assignment project which are edible and poisonous mushroom classification using neural network. So first, our group consists of me, Sakina, Rona Salma, Muhammad Syami and also Fahmi.
Introduction. Mushroom identification poses a significant challenge due to the existence of both edible and poisonous species. Misidentification can lead to severe health consequences, underscoring the importance of accurate and reliable classification methods. Therefore, in this presentation, we delve into the application of CNN to help identify which mushroom is edible and which is poisonous.
So let's move on to the detailed description about our dataset used in the project. So our project dataset consists of 447 real image of mushroom, a near even split between edible and poisonous varieties, which is 221 and also 226 edible. So we have even split, nearly even split, and these images is in both PNG and also JPEG format. This is to capture the diverse appearance of mushroom, and we also cater the resolution where the resolution is varied and focus on um, the characteristic of the mushroom, which is the shape, the color, and also the texture. So these are the key of identifying the feature of the cap or the mushroom. So, despite the challenge posed by natural variation, which is on the variation of the species, the differences in image quality, this dataset is actually good to serve the project as a valuable resource for us to train our model, our neural network model. And by learning from these images, we can or we aim to develop a reliable tool to let human distinguish between edible and also poisonous mushroom. And we also hope that this data can serve the humankind to contribute for safety and also knowledge for all.
So for the flowchart of this project, okay, next we go to the step-by-step learning and analysis.
Next, we're going to talk about technique used in this assignment. It can be divided into 3 parts, which are data preparation, training method, and also testing method. For data preparation, we label our data set based on the file that is located as. There's 2 files which are poisonous and edible, and the image in the edible file will be labeled as edible, and the one in the poisonous file will be labeled as poisonous. We only accept PNG and JPEG formatted image since it's the only format that is supported by the toolbox. And then the dataset will be split into 60% for the training set, 20% for the testing set, and another 20% for the validation set. Next is the training method used to train the model. In this assignment, we use a method called transfer learning, which are the reuse of a pre-trained model on a new problem. Transfer learning is a technique in machine learning in which a knowledge from a pre-trained model is used for a different task, usually for a similar problem such as classification. In this case, we use a ResNet 18 which are used for image classification to classify an image of a mushroom, if it's an edible mushroom or if it's a poisonous mushroom, based on the dataset that we provided them. Lastly is the testing method of the trained model. We use validation accuracy, which means we tested the model for each iteration to check if the accuracy increases or not, and we also check for confusion matrix of the trained model. From the confusion matrix, we get the values such as true positive, true negative, false positive, and false negative, which can be used to calculate the accuracy of the model, the recall value, the precision value, and also the F1 measure of the trained model.
6. How analysis conducted. First, for dataset preparation. We applied the analysis to the training dataset comprising 80% the total data to enhance model performance and avoid overfitting. Second, data augmentation. To increase the diversity of our training data, we introduce random change including rotation minus 30 to 30 degrees, reflection along X and Y axis, translation up to 10 pixels, scaling 80% to 120%. Third, for data splitting, the dataset was divided into 70% for training and 80% for validation. Fourth, for model training, we train the ResNet 18 network on the augmented training data to leverage its deep learning capabilities. 5. For prediction and evaluation, predictions were made for both training and validation dataset. We create confusion metrics to compare predicted and actual levels, providing a clear picture of our model performance. 7. Finding and review. Step 18 on 71 layer deep CNN using residual learning. Start with a data layer for input image 224 times 224 times 3. Initial layer include convolution, that's in normalization, relook activation, max pooling. The network then tests through 4 stages of residual blocks with convolution, batch normalization, relook activation, and shortcut connection. The average pool layer performs global average pooling, followed by a fully connected layer that converts vectors into a 1D vector. The softmax layer then converts this vector into class probabilities with the final classification result given by the class output. And then for results of confusion metric training data, correctly classified the mushroom 92%, misclassified mushroom as edible 7%, correctly classified edible mushroom 88%, misclassified edible mushroom as deadly 11%. Overall accuracy 87% for deadly mushroom, 93% for edible mushroom. And result of confusion matrix validation data, correctly classified deadly mushroom 85%, misclassified deadly mushroom as edible 15%, misclassified edible mushroom as deadly 20%, Overall accuracy 70% for deadly mushroom, 86% for edible mushroom. Overall accuracy significant in drug accuracy containing to validation data. Increase in misclassification rates in this validation data. The model may have learned the training data too well, affecting its performance on new unseen data.
To wrap things up, I think we are safe to say that this study demonstrates the successful application of deep learning in NNN to do the task of classifying edible and poisonous mushroom based on image detection. By utilizing a ResNet-inspired model, we were able to effectively extract complex pattern and also features from a data set of mushroom and then achieve the significant result in classification. So we are satisfied but we are also optimists. We are optimistic that there is a potential for further improvement through the exploration of alternative architecture, maybe experimenting or do refine on the hyperparameter, or maybe a better data set can be used. This research highlight that significant potential of deep learning as a valuable tool to cater complexity classification challenges in the natural world. Thank you from us.
Lastly, some of the references that were used for this assignment is a research paper named A Deep Learning-Based Approach for Edible, Inedible and Poisonous Mushroom Classification, which are published in 2021 International Conference on Information of Communication Technology. And then we also have a research paper titled A New Deep Learning Model for Classification of Poisonous and Edible Mushroom based on an Improved AlexNet Convolutional Neural Network. And lastly, the research paper that we use is comparative analysis of various activation function for image classification, which are published in 2023 International Conference of Inventive Computation Technology.